Hi, this is Olawale Elegure. My final project is on artificial neural network and visualization of sleep deprivation using R software and Tableau. My case study is on signal mail workers. This presentation is in fulfillment of my final project for IFMG 556 being lectured by Dr. Rogers. And my keywords are sleep deprivation, sleep loss, decision support science, artificial neural network, and genetic algorithm. Early studies have linked sleep loss to breast cancer. Some suggested relationship between chronic sleep deprivation and increased risk of obesity. For this reason, the study is aimed at investigating the effect of sleep deprivation on the alertness of workers at work. My analysis was focused on the valid response from the participants, and all null responses were being excluded. Introduction. Sleep deprivation is a situation of not having enough sleep. Sleep deprivation effect has been linked to daytime sleepiness, weight loss, or weight gain, clumsiness, etc. And total loss of sleep for a long time has caused death in animals, though this has not been scientifically proven in men, as nobody has really gone that long without sleeping. Sleep deprivation impairs alertness. Short-term sleep deprivation produces global decrease in brain activity. And so many studies have been made that links sleep loss to so many other dangers. Uh, Friar Brown of Harvard Business Review says that staying awake longer than 18 consecutive hours causes reaction speed, short-term and long-term memory, ability to focus, decision-making capacity, math processing, etc. to all suffer. And so many fatal accidents cause has been linked to drivers falling asleep while on the wheel. And the solution to this, according to so many articles and so many websites, is that we should get enough sleep. Sleep deprivation severely impairs the encoding of both contextual and non-contextual aspects of memory, resulting in worse retention after 2 days. And so many other studies have been made that tells us the hazards of not having enough sleep. And as I said earlier, studies have shown that the only true preventive measure to drowsy driving is to get enough rest on a daily basis. There are many forms of sleep deprivation, but all of them have a negative impact on the proficiency to maintain novel information and on memory consolidation. Christopher Barnes also argued that poor nightly sleep influences leaders to enact daily abusive on subordinates via ego depletion, and these, of course, decrease the subordinates' unit work engagement. So it is advisable that everybody gets enough sleep, both the leaders and the subordinates, just to guide against the adverse effects of sleep loss. Talking about the methodology used for this research work, I used the genetic algorithm method of solving the constraint and unstructured optimization problem based on a natural selection process that mimics biological evolution. I used the artificial neural network algorithm, and my model was based on alertness. My target result was on alertness 2, which is the alertness of workers when they resume work each day. And my other variables that I included, other neurons, are falling asleep, ease of falling asleep, ease of waking up, the sleep length, the sleep quality, and how alerted they are when they wake up in the morning and how alerted they are by the end of the day's job. The objective of the model is to predict how sleepy or alert workers will be when they resume work daily, considering their ease of falling asleep and waking up, the length of the sleep, and the sleep quality, and etc. The descriptive statistics. I have two models that I used in analyzing and coming to a conclusion on this research work. The first data frame is centered on the sleepiness, the sleep alertness of workers at work, and the second data frame is on the background, the raw data, the background data of all the workers. So this descriptive statistics is showing the summary of the sleep alertness of the workers. As we can see, the ease of falling asleep, the mean is 3.8. That means a good number of the workers find it quite easy to fall asleep. And then the alertness when they wake up, the mean average is 3.4. Compared to by the time they start work, it increased to 3.7. But the reason for this increase can be attributed to probably body exercise or the taking of a caffeine or all other stimulants. Statistical analysis. A correlation coefficient of 0.61 was arrived at, which indicates that there is a linear relationship between how efficient or alert workers are at the workplace and their sleep length. I conducted a chi-square, and the test statistic is targeted at analyzing if the health of workers is dependent on the average number of hours worked by the workers. My null hypothesis is that health of workers and average working hours per week are independent. And my alternative hypothesis is that the health of workers and average working hours per week are not independent. Excuse me. Visualization of results. I use Tableau and R to aid my visualization. This slide, the result was actually generated from R. And the graph shows that the workers attribute high scale of alertness to weekends, to Sundays and Saturdays. Excuse me. And this is because they have enough rest, enough sleep, no job pressure on those days mostly. So they have enough sleep on those days, and they say they are very much more alert on those days they have enough sleep. Still on our visualization, the first graph shows us the density of sleep loss, and then it shows that about half of these workers agrees to the fact that they experience one sleep loss or sleep deprivation form or the other. And then the graph on the second side, on the right side, shows that there is a relationship between the average number of hours worked by workers and the sleep loss experienced by workers. As we can see, workers within the range above 45 hours of sleep falls under those that complain that they experience one form of sleep loss or the other. This slide also is on visualization as well. The graph shows the relationship between average number of hours worked per week and the alertness of workers at work. We can see that the level of alertness of workers reduced drastically at the point where the number of hours worked per week was above 45 hours. The scale of alertness is based on 1 to 4. 1 meaning I am not at alert. I'm not at alert at all. 2 meaning I am occasionally at alert at work. 3 meaning I am frequently alert at work. While 4 means I am always alert at work. And looking at this graph, we can see that more of the workers fall on 2, which means they are occasionally alert at work. And the company needs to look into this in order to make sure that productivity doesn't suffer based on this deform. Also on visualization, this graph shows the density of alertness of workers at work. We can see that about 90% of workers' alertness was clustered around 2 and 3, which means approximately only 10% of the workers always are always at alert while working, which is very counterproductive for the company. In order for the company to improve its productivity, they need to dig down into the sleep deprivation or the sleep quality of their workers and try to manage them well, ensure that there is less job pressure and that they have job security and that there are adequate staff such that no worker will be working 80 hours, 60 hours plus as seen in the data. This slide shows us the result of the artificial neural network. The analysis shows an error of 16.4 out of 82,801 steps taken. The correlation of the prediction values and test data is 0.68, which is quite reasonable. At 68% correlation, it shows that the model is good and can predict the alertness level of workers based on length of sleep, ease of falling asleep, ease of waking up, how they feel after each day's work, how they feel when they wake up in the morning, the sleep quality and the sleep length. Conclusion. My test statistics shows that health of workers is dependent on the average number of hours worked weekly. Workers with high average working hours weekly are prone to feel unhealthy. The ANN model shows that we can predict the alertness of workers at work based on if they experience any form of sleep deprivation and how they feel at the end of each day's work, their ease of falling asleep, ease of waking up, etc. Based on this research work and analysis, I recommend that each company review the average hours and stress level of their employees, as this goes a long way in the efficiency and well-being of their workers, which in return affect the productivity of the organization. Workers are also encouraged to improve their sleeping habit by sleeping for an average of 7 to 8 hours daily, as recommended by NHTSA, so that their level of alertness at work and while engaging in other life activities such as driving, etc., will be very high. This slide shows the list of my reference for this study. Um, I hope you enjoyed my presentation. Thank you very much. I would say I also really enjoy the class and the lessons learned from this class. Thank you. Bye.